Hello, my name's Roger Hay and I'm System and Projects Manager at Western Power Distribution. My team look after the innovation and the control systems that sit behind the power network. In both teams, what we aim to do is to exploit the best that technology can deliver to keep your lights on. Today, I'm going to update you on how our energy system is changing and what that means for technology control systems and supporting telecommunications. I'll introduce you to Western Power Distribution, a quick recap of what's happening in the energy environment, and then explain how we're responding. I'll then focus on the 3Ds, that's data, digitisation and digitalisation, and how these are set to transform energy networks over the coming years. Finally, I'll finish with a quick case study and touch on cyber security. Of course, I'll be looking forward to discussing further in the panel session. Western Power Distribution, or WPD, is the largest electricity distribution network in the UK, and we cover around 25% of the country, and we serve about 8 million customers. We own, operate and maintain the network of wires, cables and substations that transport energy from the big power stations and renewable generators to homes and businesses across the Midlands, South Wales and the South West. Whatever the weather, our 6,500 strong team of technicians, engineers and apprentices keep the lights on across our regions. And we've been doing this throughout the pandemic. Our people are very proud of the contribution they've made as some of the hidden key workers who've kept homes lit, businesses functioning and ensuring that our hospitals have got the power they need to care for us. We do all of these services for less than 27 pence per day on your household electricity bill. The network is huge. It's got enough cables and lines to go around the world about 5.5 times. And traditionally, the network was designed to be passive in operation. That means it was designed to support one-way power flow with electricity shipped to us via the national transmission grid from those large power stations. Such a system didn't need a lot of monitoring because it was designed for relatively predictable load growth over its 40 or even 50-year lifespan. But energy increasingly comes from distributed resources, which are connected directly to our distribution network. It's also largely renewable, such as wind and solar, meaning our output is less predictable. And our low and steady load growth assumptions that we'd made for 40 or 50 years have been completely destroyed by the introduction of electric cars and heat pumps. This means we now need to monitor, control and automate the electricity grid like never before, allowing customers to adopt low carbon technologies at the pace they wish without simply us building a bigger grid to maintain the old passive way of operation. Luckily, what we've got is the information and communications technology solutions to make all this possible. And we've already begun digitizing the grid, as I'll explain later. Finally, we take our responsibility as a network owner and operator really seriously. We not only serve our communities, but we're part of them. It's where our team live, not just where they work. So we really understand how important safe and reliable energy really is to each locality in our region. Now, I'm an engineer by trade, and so like every good engineer, I tend to think in numbers. According to RAC figures, the UK currently burns around 130 million litres of petrol and diesel every day. If we turn that into electrical energy equivalent, that's around 1,500 gigawatt hours. What does that mean? A big number. But for WPD, that means we'll be tripling the amount of energy we deliver to our customers every day. And what about at your home? Well, an average electric car doing an average mileage will use about the same energy over a year as the home does itself. So these are really big challenges that are coming. But we're ready to meet this challenge. And we've actually done it before. We've done it with the boom in solar and wind generation over the past decade or so. We've already connected 9.9 gigawatts, nearly 10 gigawatts of localized generation directly to our grid. Just to size that, that's 3 Hinkley Point C, the new nuclear reactor that is being built. That's 3 of those. And we've done it without any fuss and actually very little cost. Sometimes we wonder how other infrastructure providers make it look so difficult. We've got a long and successful track record of developing our grid in line with customer changing needs. And since 2010, we've offered connections to over 21 gigawatts of distributed generation on a system which I've already said was largely built for unidirectional power flow and passive operation. We've developed a toolkit of solutions to incrementally adapt the network to accommodate for these active flows. And the toolkit contains lots of smart technology, as well as commercial arrangements and more conventional engineering redesigns. We've also made changes where necessary to policy, for example, lowering design voltage limits, where such policy action can create capacity without impacting the integrity of the grid. Most of these solutions are technology based, and they were developed under our research, development and demonstration innovation programs. Some solutions have progressed rapidly from concept to full deployment, while others take a long time to mature so that we are confident and safe they can be deployed on the system. And our innovation engineers continue to identify new opportunities and new technologies all the time for us to be able to meet future challenges. And key areas at the focus, not surprisingly, you'll be not surprised to hear their electric vehicles, heat pumps integration, and interaction with smart homes and energy management systems in the home. Our leadership is not just evidenced in what we're doing to the grid, it's what we do as our business ourselves. So we've segregated our system operation functions at the request of stakeholders, rather than waiting for Ofgem to mandate such action, which we think is inevitable at some point in the future. We lead by example, and we're doing the same with our business carbon footprint, with the reduction of energy uses in our offices, reduction of electrical losses across the grid, and the deployment of electric vehicles wherever possible. You can probably tell that I'm very proud of our track record, and supporting the UK's low carbon transition is not just about facilitation and compliance for me. Our business is about decarbonising and helping businesses decarbonise so that we can meet our net zero goals. Now, about those 3 Ds, let me introduce them to you. Data, well, that's just mostly numbers. It's got little value in itself, but it is the foundation of operating a smarter grid. Our passive network, these designs are tried and tested, and they've got lots of assumptions baked into them. These assumptions are things like, for example, assumed line ratings of transformers, or worst case assumptions for the amount of generation on the system and what that means for network voltages. If we can replace these assumptions with measured values or just better estimates, this is the basis of the smart grid. And I call the process to get data that we can then make decisions on, I call that process digitisation, the second D. And we've already begun to digitise the grid. Over many years, we've continued to add telemetry equipment to our substations. We've already got tens of thousands of endpoints connected over our secure and resilient SCADA networks. All larger substations and new generators and battery energy storage sites connecting to the system now must have telemetry fitted as standard. Plus, we're progressing a large retrofit program at over 1,500 generation sites, which are over the 250 kilowatt limit. We're also deploying telemetry and monitoring to over 2,000 distribution substations. These are the substations where we do the final transformation of power on street corners before we deliver it to homes and businesses. These 2,000 sites are where we are predicting large uptakes of low carbon technologies, or we've already started to see electric cars starting to cluster in particular areas. We need the monitoring to ensure that the network isn't overloaded and that we can keep the lights on in a safe and secure way for all of our customers. We'd also hope to make much more use of smart meter data in the future, once the rollout has got to a point that we've got sufficient penetration of meters in order to be able to make decisions. And I'm as frustrated as anyone that the smart metering programme has taken as long as it has to get to where it is today. So what about the third D? That's digitalisation. Well, that's all about exploiting data and the capability of a digitised grid. And a bit more of that to come in a moment. The slide in front of you sets out some of the things we need to do to our network control systems to support digitalisation. It's a long list, but it's not exhaustive. It's got three main elements. It's around exchanging data, it's about gathering and processing data to deliver actions, and doing so in a way that is actually future-proof. To be future-proof, we're guided by what's called the smart grid architecture model. This is an international standard in the development of smart grids. And there's lots of things we need to do. Lots of people we need to interact with. We need to make sure that we've got the equipment for doing the substation and network monitoring. We need really good, high-performing, resilient telecommunications everywhere, absolutely ubiquitous telecoms to do it. We need to get the best out of algorithms, artificial intelligence, machine learning type techniques, so we can automate the grid as much as possible. And then we need to make all this information available through APIs, data hubs to third parties. So digitalisation, well, it's key to the UK, this clear commitment around net zero decarbonisation by 2050. We have to digitalise the energy system. We've recently produced a digitalisation strategy and an action plan. You'll find that on our website. It sets out our commitments for how we're going to digitalise our business to make sure that we're efficient and effective operator of the grid, and how we'll deliver data and solutions in the right format at the right time for the customers that want it. Our focus is to also improve data management, increase the amount of network insight we've got, and we will assume that all data is presumed open, so therefore we can share it. It will be the exception that a piece of data will not be shared rather than the other way around. We recognise the importance of digitalisation and data now moving forwards, and we've set up a dedicated team within our DSO department to be able to progress our overall data activities. This is going to be able to make sure we can work with our stakeholders closely and meet their needs. And we've published an action plan that's being co-created, and we'll be continuing to share data and get feedback on what we've done so we can continually improve. All these steps are in line with the Energy Data Task Force report, an Ofgem government group that made a series of recommendations and expectations on us around how we would digitalise the energy system and our role as network operators in that. Our overall digitalisation plan is going to be completely revolutionary for our business. It's going to deliver tangible and real results for customers, and they're already benefiting from better insight in the grid, and I'm pleased we're going to be able to progress this much further. Let's have a look at a case study for what data, digitisation and digitalisation actually mean, and I've picked flexibility services. We continue in Western Power Distribution to be the leaders in flexibility services in the UK. We've got the largest marketplace and the largest volumes by some distance. We've been procuring flexibility services from customers, generators, storage operators, and final demand users who can vary their input or output according to our needs since about 2018, so over 2 years. Last year, we procured over 184 megawatts of services, and that accounted for about 15% of the grid. And we've deferred huge amounts of money in terms of conventional asset build from what we've been doing so far. We've already gone out for more in 2020, and we've got at least 2 rounds of large volume flexibility procurement this way. But flexibility services don't happen without data, digitization and digitalization. Because first of all, to identify areas that would benefit from flexibility, we need measurement points on the network. We don't just need to know whether a network is overloaded. To buy flexibility, we need to know how much it's overloaded, how often, and how long for each time. The number of occasions and duration that drive the economics. So this is different measurement data that we would normally have on the grid. Once we've got the data and we've contracted some flexibility, well, we need to know when we need to contract it. If we do it too often and we're too conservative, it will turn out to be really expensive because we'll be calling it when we don't need it. But if we don't use it enough, it could damage our assets, or worse, it could potentially cause power cuts. So having good quality data to know when to dispatch flexibility suddenly becomes completely mission critical. So therefore, the systems that support them in the telecommunications grids have to be reliable, resilient, even in a storm, and highly secure. We've already got over 200 distributed energy resources providing us with services, and they all need to be metered and controlled. But this is an activity that isn't done by network operators. It's organizations who are unregulated called aggregators, who actually are the intermediaries between us and the flexibility providers. So we have to integrate with their systems and work with them hand in hand in order to be able to share and control these assets. Now, I couldn't speak to an audience like this today without acknowledging cybersecurity. But sadly, we do live in a world where the bad guys want to attack us based on the very technology that we're deploying to deliver secure, zero carbon and safe electricity supplies. I naturally am not at liberty to discuss the specific measures that we have in place, but what I can do is oppose some of the high-level themes to you as questions. So first of all, I'd point out that with a smarter grid, there is a much larger attack surface. The bigger the attack surface, the bigger the threat. Our networks now sort of extend beyond the sort of physical and electrical boundaries that we maintain, and so it's much less clear who looks after what. Often we have separate operational technology or OT departments to our internal information technology or IT departments, so they need to work closer together. But actually, a lot of the vulnerabilities and the risk actually sit beyond the meter in the customer domain with the distributed energy resource, with the generator, the battery storage, and the complex control systems they have. It's this customer technology space that we're spending a lot of time and effort looking at. The explosion of endpoints is set to continue with different technologies and different devices connecting all the time. So this isn't a one-stop shop, one-step process. This is going to be constant change. We've also got a real mixture coming on now of advanced modern technology and legacy technology solutions. With the advanced technology solutions, security, yes, we can build it in. It can be standardized. We can use commercially available off-the-shelf products. Makes it much more accessible to us and easier to integrate between systems. But that means it's also easier for the bad guys, for the hackers, to potentially access. And the legacy technology, well, we've got a little bit of security through obscurity, as they call it, but it's very difficult to protect from existing and emerging threats. So we need to up our game in that area too. One of the problems we've got with buying modern technology is it's standard. That means you often get what you want, but you sometimes get a whole bunch of functionality as standard that you didn't want. Well, you need to protect the things you didn't want as well. So this is a much more complex system going forwards. The usual operator and system errors. We've got very complex software and firmware environments, new exploits emerging all the time. The whole program around firmware and software and security patching is huge. How do you go about patching a highly distributed and constantly used live component that is a fundamental part of the energy system? So lots of considerations in the cybersecurity world too. So for my closing remarks, I just want to re-emphasize some of the things that we're doing. Our principles are that solutions we develop should be accessible. We want our solutions to be accessible by all customers, especially, and we especially want to sort of target opportunities where our most vulnerable customers can benefit. We want to be fair, so all customers are equal, but I want to include support for emerging community energy groups. Some of our local community energy groups are passionate about keeping bills low, decarbonising the grid and serving the communities they serve, and we want to help. Secure, all our systems have to be fully risk assessed, and we need appropriate mitigating actions in place. Dynamic, because the world is going to continue to constantly change. This revolution isn't over yet. If anything, it's continuing to accelerate. Government policy isn't yet clear, but when it is, and our customers have got a clearer set of requirements, we'll be ready to adapt and change and follow them through. And finally, we want to leverage technology to be sustainable. We want to support the delivery of these net zero 2050 or before goals as much as anybody else. That is one of the things that really drives us around this smarter, cleaner, more sustainable energy system of the future.